Okay, latitude weather and how might it be a little different? Maybe we're looking at a smaller scale. We were talking last week about monsoons. We were talking about global highs and global where predominantly low pressures occur. Well, now we're going to go focusing down into air masses and fronts and extratropical lows. And before we go too far, I want to make sure that you understand there's a difference between an extratropical low and off of New England is an extratropical low. However, down here off of Mexico is a tropical low. They are different structurally. And I want you to understand that this week, that there is a difference there. So what are we looking at here? Well, I wanted to show a comma head. This low is really developing quite nice. There's almost, here's your cold front, warm front probably out in here somewhere, occluded front wave, almost like a comma shape to this whole system. That is an extratropical low, what it has. So with that, let's go looking some other areas here a little bit. So currently, there's your low sitting off of New England. It's already down to 980 millibars. It's a pretty impressive low. Here's high pressure coming down out of Canada. Well, one of the things we're going to talk about this week is air masses. Air masses have generally the same type of air over a large area. So, and think about it. If you have air sitting up over Canada, it's going to take the characteristics of what is Canada, the ground. Canada probably has snow in the winter, doesn't have as much sunshine, doesn't have a lot of water. So you wind up with a fairly cool or very cold air mass that's fairly dry. By the same token, if I have an air mass that's forming out over the Caribbean or over the Southeast Atlantic, the air is quite humid. It does have plenty of sunshine to heat it with, may not even have a front that crosses through it. So it's going to be a hot or warm, humid air mass. So there we just have two source regions. One is over the tropical Atlantic, one is over Canada. Say you were looked out in New Mexico or Arizona. What do you see out there? Like a desert, right? Not a lot of moisture, not a big area, but enough of an area that you can actually form an air mass that's hot and dry. And if you want to go up off of New England, out over the North Atlantic, what do you get? Moist, cool air masses. So they're maritime air masses, polar. So there you have your basic four air masses. Where they come together is along the front. So I have cold air coming down out of Canada. Why is it stopping right here? What stopped it there? Why didn't it just keep flowing all the way into the Pacific? Well, here is where topography, a little bit of knowledge of it, can help. Right along this area is the Rocky Mountains. This air mass is running into the Rockies right there and stopping. It's not having enough depth to get over the 10, 12,000, 14,000 foot peaks that are out there. So it stops. It goes down south where there's no topography and comes east where the topography isn't as much. So that is why that air mass is stopped right there. That cold air is coming down out of Canada, but it's not moving west. And we have here the extratropical low that I was talking about. Notice the occluded front. What is an occluded front, you might ask? Well, an occluded front is where you have a warm front that was caught by a cold front. Think about it. If you have warm fronts that are moving out ahead of the low, and the low and that cold front that's with the low are moving faster than that warm front, cold air is denser, so what it does is push that warm air up above, so it winds up being aloft. So you wind up with two basic cold air masses touching each other. That's the occluded front. Sometimes on one side of it, it'll be cooler and the other side will be warmer. Or sometimes it's warmer, a little bit warmer, and the other side's cooler. But they're both cool air masses. The warmer air has been pushed aloft. So I want to also show you why it might be developing. Look at this 300 millibar jet. We talk about the wintertime jets being stronger than the summer times. And we have 110 knots in here of winds. We have 130 knots in here of wind. Left front, right rear quad of a jet is going to have the best divergence. It's going to have the best lift. I would argue that this is the right rear quad, maybe. The stronger winds are actually right in here. So this is where the best divergence is occurring. We also have another jet coming in this direction. Left front. We actually have divergence from two different jets, the one to the west and the one to the northeast. Sometimes that happens and they get our most intense lows. That's why that nor'easter is really developing up there right now. So let's go from here and move on. I wanted to really show you a little bit, go through some slides again with you here. So we'll see if we can talk a little bit about what I just showed you on the weather maps. All right. So we're going to really want to talk about where the air masses are coming from. And here's where I was just telling you about all of the different air mass locations that can occur that can impact the United States. And where they meet is a front, either a cold or warm front. So with that, let's think about what happens. If you have a stationary front, what did I show you out there in the Rocky Mountains? It was a stationary front. It wasn't moving anywhere. So on one side of it, the warm air is lifting up and over it. On the other side, the cold air is below it. So you wind up the warm air slowly flowing up over top of it, which is why you may have some clouds on the east slope of the Rockies right now with this getting lifted up as well, and the warm air coming in dry. That's why you don't have much. But these two combine to make some higher clouds. And on the cold side of the front, you're always going to have the denser air. So it's always going to be the warm air rising over it. So let's take a look at a warm front. We did have a warm front up off of New England there. We had very nice southerly flow into that warm front. And that warm front was advancing. And what happened was, but on the ground, where it hasn't got past that cold air yet, the warm air is rising. Interestingly, if you were to fly in an airplane, you might take off, we'll say if this was Boston up here to the north, and fly through into the warm front, fairly short distance out. However, if you kept going, you'd finally have the warm front at the surface, and you might just have changing clouds, the changing weather. So, interestingly, the warm air comes in aloft, and you get a warm front that slopes in the vertical. So that is why it's not as steep on a warm air front. It's very steep on a cold front. Have you ever noticed a bulldozer pushing dirt out ahead of it, and that you get this big pile of dirt, but as it's moving, the dirt actually rises out ahead of the initial edge of that pile of dirt, well ahead of it. And what happens in a cold front is the same thing. You get the air being pushed up, the warm air is being lifted, but it's being pushed. Initial rising of that air is out ahead of the cold front. That's why the showers, thunderstorms, and all develop out ahead of the cold front. That whole mass of air is being moved, and the initial lift is being to the east or out ahead of the cold front. So there's where you're getting your colder, the rain coming down. And because of that, you may have some heavier precip. The air is steeper. Fronts can move in all different directions. This is a backdoor cold front that typically develops on the East Coast sometimes. What happens is you get a high pressure system that's developed over the Maritimes of Canada, pushing cold air down the mountains. It's hitting, winds are blowing right into the mountain range. Well, if you have winds blowing in, they're rising there, but they keep coming in and they never go anywhere west. What you're actually doing is raising the pressure. So the pressure is getting higher. You're building up a high pressure system along the mountain chain. You push this cold front down, and you wind up with winds coming in off the ocean, and it's miserable. Doesn't happen frequently, thank goodness, but it does happen. Occluded fronts, I showed you one earlier. All they are is two cold air masses meeting, and the warm air has been pushed aloft. And depending on whether it's a warm occlusion or a cold occlusion, is which kind of a cold air. Is the cold air to the coming in behind the occlusion, having slightly cooler air ahead of it, or is it just a little bit cooler behind it and colder out ahead of it? There are different kind of occlusions that we're going to see. The Norwegian cyclone model says, okay, this is how an extratropical low pressure develops. First, you wind up with a temperature contrast to start. There is some kind of front there. You wind up with a trough aloft or upper air low pressure, which has a jet streak with it. Now you've got divergence. What happens with that divergence is, air is being converged, pushing together. You increase the temperature gradient because you're pulling air in towards the cold air from the east. All convergence is occurring. As it deepens, you begin to get a calm ahead because the cold air is being wrapped back aloft. Stronger it gets, the actual low gets closer and closer to the upper low, and eventually they're vertically over top of each other, and that's when you wind up with no more development. However, notice what we call a triple point here. There's another warm front that has developed. Here is your occluded front, and here's a cold front. Many times after a while, you wind up getting development off of this triple point, and a new low develops. This frequently happens along the east coast of the United States. And that new low may develop in the Carolinas, Georgia, somewhere in there, and then move up the east coast. So now that we've seen all of this wonderful stuff, here is another way of looking at it. And this way it talks about basically temperature and moisture. So we wind up with high pressure, usually to the west of the extratropical low, bringing in dry, cold air. So if you get that air wrapped into the backside of the low, what you wind up with sometimes is a dry area. And with that dry area, your precip cuts off. You may get rid of some clouds. And eventually, the cold air is going to come in as well. Now, you have some cold conveyor belt at low levels, typically coming in off the ocean or maybe coming from a cold high pressure to the north, wrapping to the west. That cold conveyor belt is what forms the comma head. It moves up and keeps rising up and then back around, gets picked up by the jet stream and moves back to the east. It forms a comma head shape. You get different kind of weather in different sectors of the low. If you're in the warm sector, you're going to have more thunderstorms, better chance of maybe severe weather. If you're in the cold sector, you may have more snow. So it depends on which sector of that low as it's going by. And that is one of the biggest problems of forecasting. We want to know exactly where that low is going to pass in relation to your house. Here, for example, is a low that's coming up. And if I told you 24 hours or 72 hours out that this low is going to go west of Chicago, Chicago would then be looking into getting into the warm sector, maybe have a thunderstorm, some rain. However, 24 hours out, everything in my mind just changed. And now I'm going to move that low up over South Bend, maybe 100 miles to the east or 50 miles to the east. All of a sudden, Chicago stays in the cold air, does not get the thunderstorms, and gets snow instead. So a very, very different forecast based on where that low went. Same thing happens in Ohio, West Virginia, Pennsylvania, any of those areas. If the low is moving to your west, you're going to get into the warm air. You may start with some cold precipitation like snow, but eventually the warm air will arrive. It will change over to more rain and maybe even showers or thunderstorms. If you can stay to the west of the low, better chance you're going to get all snow. Extratropical systems are cold core. In other words, they get stronger as you go up, and they get colder as you go up. Both happen. Sometimes you get what they call non-occluded cold core systems. These are just weaker lows that are moving along. Warm core systems. Well, okay, we know that the air is less dense in a warm system, so it weighs less. So if I go down over the desert Southwest in the summertime, I'm getting to 120 degrees maybe. That air is very, very light, very fluffy. And because of that, it doesn't weigh a whole lot. Low pressure forms. Okay, what happens in the vertical then? Well, we know that pressure does not drop as fast in the vertical because the air is very warm. So instead of getting this intense low aloft, you wind up with a ridge of high pressure. Guess what? This can also be a mirror image of what we're going to talk about when we talk about tropical systems. Tropical systems are warm core. Other local wind circulations here are sea breezes. Lake Erie is a classic example. Land breezes can occur. Valley breezes. If you lived in West Virginia, some of the mountains there, if you think about in the mornings maybe, all the air has been sinking all night long down into the valley. It's cold, it's foggy. Up above that, the sun now starts rising, starts heating that upper part of the mountain. Guess what? The air is going to want to rise up into that part of the circulation because that air has just gotten warmer up there and it's starting to lift. So it's going to pull the air out of the valley and then back down into the valley from above, warming it. So you get these type of wind circulations in the valleys. So I hope you got a little bit out of this. Let me know if you have any questions.